Greetings, Earth enthusiasts. If you ever wondered about the incredible perspectives our planet has to offer from high above, you're in the right place. I am Dr. Clive Coetzee, and I'm thrilled to be your guide on this captivating journey into the world of remote sensing. Welcome. And please remember to like, subscribe to, and share this video. Thank you. In the previous tutorial, we created histograms of the temporal difference nighttime light intensity images. And we then exported them as CSV files, and we in Excel then converted them into to Excel spreadsheets. And obviously from there you can do a number of typical uh, analysis, statistical work on those data, like descriptive statistics and so forth and so forth. So what we're going to do in this tutorial is to look at creating a time series or generating the time series data for each of those data sets. So we go to our Earth Engine as per normal. We click on the code editor. From code editor, we then search in the scripts column. We search for our script. We double click on it, and as I said, I always, as a matter of course, run the script and I save the script. That's my first steps. Okay, so remember in the previous tutorial we've created the histograms, and then we indicated how we're gonna export these histograms via this little button and into CSV, into Excel. So that's obviously now possible. What we want to do now is to take each of these data sets, the DMSNP data set and the VS data set, and we want to create a time series from 1992 to 2013 for each of for the DMSP, and then from 2013 to 2023 for the VS. So the time series for the DMSP will be an annual time series, because remember that the images are only available in the Earth Engine in annual format. So for in DM we'll create a annual time series from 1992 to 2013, i.e. 23 years. And then for the VS, we will create a monthly time series from 2013 to 2023. Just remember, you can find the date specification or the time period specification, which is going to be important to correctly specify for each of these data sets within Earth Engine. So let's just do that as a matter of, so I go to the Earth Engine, I click on data set, and in the search bar, I just copy and paste that unique identifier. It will find the data set. I'll just press left click on it, and it says 1992 to 2014. Well, I'm going to make it 2013. And then for the viewers, let's just collect that, copy that, same place, go to data set, paste it into the search function, double click on the heading or the name, and that's from 2012, the 4th month, until 2023, the 9th month. Okay, so let's keep those dates in mind. So, and remember, the bands are the average verse and the average radians. Remember, there's the bands, average verse, and average radians. The images I'm generating using the mean function. Okay, so we display it, we export it, we generate the the histograms. There's the histograms, etc. Now that we want to create a time series, and oh yeah, by the way, remember, if you want to type something that should not be run as code, you always start with 2 / signs. So if you just type it like that, it will give you an error, and therefore your code won't work. So you just basically do 2 /. It becomes green, which means it's just text. It's not part of the code itself. So in terms of creating a time series, you always start by creating 2 variables, a start date variable and an end date variable. In this case, our start date, and this is for the DMSP, our start date is um, January 1992, and our uh, end date is December 2013. But remember, this is annual data, but we still specified in that form. But so this is start date DMSP and end date DMSP. Now remember, I'm calling this because if we create the VS one, you can't have another start date and an end date because you can't have multiple variables with the same name. Okay, so I specify my time period, and obviously it's up to you to discretionary to change these dates if you want to, but anyway, let's keep it there. Then I'm going to enter the next set of code where we say we create a variable which is the number of periods within that time period. Remember, I've got now end date DMSP, and I've got start date DMSP. Okay, let me just do that as DMSP and end date DMSP. Okay, so I'm calculate the number of periods within my time frame. So I'm just taking the end date, and I subtract it from the start date, and I generate it and I specify that this is yearly data. If we had monthly data, I will change that into monthly, or if I have weekly, I'll change it to weekly, or whatever the case is, and around it's just round it off, like in make it a whole number. So that's the code. So I've generated my beginning date, my end date, and I've calculated how many months, or in this case, how many years, how many periods are there within my time frame. Then I specify the image collection that I'm going to use, and I'm going to use my DMSNP. Similar as previously, I then indicate the band that I'm going to work, and then I'm going to start. The filter date will be um, the start date and the end date. Okay, so that's sort of similar copy and paste to the previous. I must just make sure that there is no variable that has the same name. So we must just make sure that that name there isn't specified before, otherwise you're going to have a conflict. Okay, so we specified the beginning period, the ending period. We've calculated the number periods within our time frame, and we specified that we want to which data set we want to use, which band within the data set, and the time frame of the images. So we want to collect all the images basically in that collection. Okay, so now the next set of code basically tells or instructs the code editor to generate the statistics from each image for each year. So we're going to create another variable, a couple of variables by period. And again, these names are totally discretionary. So it's the image collection, this one, that we're going to use. So we're referring to that image collection. And then we're going to match each image to a specific year, which is basically this. And then we're going to advance that image year by year by year. So that's basically what we're telling the code editor here, is take that image collection, take each image and overlay that on a year, and then advance the collection by 1 year at a time. So that's basically what we're saying there. And then we're saying we're going to generate a mean image. Okay, so in this case, I'm not using a median or a sum, I'm using a mean. And again, that's discretionary. Ideally, I want to use the sum. So let's rather use the sum. And the simple reason for that is if I uh, move it into Excel, then I can, from the sum, generate my own mean and medians. But if I've got the mean or the median, I cannot generate the sum. And so that's why I prefer to use the sum in this case. So this is the code which basically generates a statistical value, a data value for each image, meaning for each year from those images. So that's basically what this code is all about. So that's the nuts and the bolts of creating a time set. And then I'm basically just printing here by periods DMP, meaning this one here, where I've calculated how many years there are. So in this case, I'm printing this particular variable, meaning how many years or periods are there in my time frame. So that's what I'm asking the code editor to present there. Then I've got two methods of plotting the data, and I'm going to display both of them. The one is where we plot it as a time series from the beginning value to the end value. And again, I'm just going to change the mean there to sum. So I'm presenting the data as a normal graph, a line graph from my beginning period to the end period. So that's what I'm presenting there by period TMSP, which is this variable here that I'm presenting on the graph. I'm doing it for my region of interest. I'm summing it. Scale, you can change the values, you can play around and see, and I'm giving it a title. So that is what I'm presenting there. In this plot, I'm presenting it per year, not over a period of time, but the values per year. So if I have one value per year, I would have a graph that displays one value per year, meaning annual data. And you'll see the difference there for now. So again, what I'm displaying, the image collection, I'm displaying this whole thing again, which is basically the data per image per year. The band name, and again, you can call it, it's that value there, the band itself. The region of interest, again, let's just use the sum value here, scale, and I'm giving it a name. In both cases, I'm giving it an identical same name, but you can change it. And let's click on run. Okay, start date must be there. You see, this is what happens. You'll see you'll get these error codes, meaning in 147, our start date is not defined because I have, it must be DMSP. Let's see if there's other places. Let's run it now and see. It should be all good now. Yep, no reds, no errors, no nothing. So let's have a look and see. Okay, remember the task. We'll ask again to export the images. Don't worry about this. Let's make it a bit bigger. Let's rerun it. Sorry, let's run it again. I wanted to make it the window a bit bigger. So remember to save your data or to save your script. So there's your standard histograms that we've calculated in the previous video. Okay, there is my first time series graph, which is the DM, the night light intensity per year for my region of interest over this period of time. And you can see the value in 1992 was 95,000. The value in 93 was 89. Value in 94 was 213, etc. And you can remember, you can export it and you can download it into a CSV file. So it indicates, if you take out this little peak here, it indicates a nice increase of nighttime light intensity from 1992 till about 2002, 2002. And then from 2002, a consistent decrease in nighttime light activity. Almost two periods. One period of increase from 1992 to 2002, and then from 2002 to 2013, a continuous decrease. Now, the reason why it started decreasing in 2002 is because interest rates went significantly up during the period leading up to 2002. But anyway, yeah, you can now go and have a look and see what have potentially caused this. Then if I go to my second graph, remember, I will only have, let's make it bigger. This graph doesn't look nice, but remember, I'm talking yearly data, so it will only display 1 point per year. It won't have multiple values because this is presented as a value per year. And you can simply, compare the data. And again, you can download the data as is. So that's quite neat. It gives you a nice um, graph of the actual underlying data. But remember, this is the values for the whole of my region of interest, not for a specific area or specific location within my region of interest, but for my whole region of interest. So that's for this whole period, for this whole region. Okay, so not for a specific. So what we can obviously do further, and we'll do that again, is to generate similar statistics time series for multiple regions or multiple locations within my region of interest, because this might be um, uh, uh, not it doesn't it's not may not be representative of all the locations. So that's creating a time series for my DSMP. So let's copy this code and let's create a time series for my viewers. So I'm just gonna go to the heading and make it viewers time series. Now, what is important to remember is our start date. Let's call that viewers. So all the places where it says DMSNP, I must remember to, or you must remember to change to viewers. Now, it's as I said, here it comes important. So let's go to the so 2012 04. So I can make that 2012 04, and the latest image is, sorry, not that one, latest image is 2013-09. So, actually 2023, 09. So, as I said, keep consulting the source pages for those data sets to see if there's any changes in dates, etc., etc. Okay, so just make sure. Remember, I'm going to use now, so let's change that as well to VS. Remember, in this case, remember, important VS are monthly. So I'm going to change that to monthly. Or is it month? Let's quickly run it to see it's monthly or month. Okay, so it seems like it's called monthly and not month. When the previous one, it's called year. This might call, let's see, it seems like, yep. Um, it's called monthly. It seems to be working. By the way, that print code there, print, this is the image collection that it says there's 23 years. So there's 23 years from 2019 to 2013. It indicates there's 23 years or 23 images in that collection. Anyway, that's just why that's there. Okay, so monthly, remember, I'm not going to work with the DSMP. I'm going to work with the viewers. Nightlight, remember, I need to replace so it's not the DMSNP that I'm working with. I'm working with the data set identifier. I'm working with the viewers, and it's called average rad. Let's quickly go back there. DMSNP. So it's open that, paste there, and it's average rad. So it's a VS nighttime lights, DMSP is VS, and we're gonna go date VS by period VS. Remember, these names are all discretionary. Ne? You can feel free to change it, and remember to change all the reference now from years to monthly. So it's not advanced by year, it's advanced by a month. I must just confirm that it's month, and I'm still going to stay with my sum. I'm just going to change that. That's VS. Let's make sure all my references are to the VS variables and not to the DMSP variables. VS monthly. advanced monthly. Okay, let's show that the month. Um, let's quickly make sure that it's all there. Um, let's quickly go DMS periods, years, let's call that years. Um, by period years, and here we're gonna go also by period years, and it's average rad. So all the references to the years, to the DMSP must be changed to the years. Okay, so I think let's save again before we do anything else. Let's keep on saving. So only thing is it called monthly or monthly? Let's run it and then we'll quickly find out. So let's quickly run it. So it says the in period, in period. Okay, there's an S there. There shouldn't be an S. Let's run it again. It doesn't look like there's any major issues at the moment. Let's wait until, let's make it a bit bigger. Let's wait until it, remember there's the DMSNP graphs. DMP, it indicates there's 23. Error generating band monthly doesn't exist, so it must be month. Okay, so that's month. And it's month. Let's make sure it's run it again. Save. Remember to keep on saving, keep on saving, keep on saving. So there's the histograms, 23 years in the DMSP. There's my DMSP time series and the two graphs of time series. Okay, so it says, okay, so I haven't changed that one there, so it's still calculating. So that's by periods, years. Then bad date time, it doesn't want to, it's now date 23rd. So let's make it 8. Let's make it the 8th month. And I have changed that to period year, so let's run it again. Oh, we're going to change that date to 0901. So let's do that as exactly the same as here. So let's do that. So it's 0901. So let's rather do that. We run it. Save. Remember to press save. So the dates are now exactly the same as they appear in the source side. We figured out it's month and not monthly. With all reference to the DMSP within the VS, we've changed the VS. Let's see. Okay, so it's generating. So now you can see there's 265 periods in the VS image collection. You can see there's 265 um, um, image collection months. Okay, properties. It says start date. That's the 1204. So that's image 1. So if we want to see image 29. That 29 is the 9th of the 14th, um, and so forth. Let's say image 251. That's the March of 2033. Let's quickly, we'll see that one out now. Let's just make that smaller. Okay, so there is, no, it's 23. It should be fine. So there is the time series. You can see obviously the difference between the two time series. This one is much more smoother because it's annual data. So it doesn't have seasonality and all these things, for example. But here you can see it is monthly data. So if we expand it, you can clearly see the months within the time series, and you can see this is the COVID massive spike drop here. We can remember we can export it, and we can interrogate and play around with this a bit more. But there seems to be a continuous increase. If you just would draw a trend line, this seems to be a continuous increase. And here you can also see if we present the data into an annual format, and you can see it's located like this. Okay, so for 22, and now you can call month to month. So yeah, for the data. And remember, it's a sum values. It's most probably not presented the best, and that's why I prefer to just generate the data in the engine. And then once the data is generated, I just export it into Excel. From there, from Excel, I can use my standard tools to analyze the data better. Um, so that now I've created not just the histograms, which on the temporal difference, but I've also created a time series of the image collection for each data set for my specified periods, whether it's in an annual format or whether it's a monthly format. And I said I've copied and pasted the one time series script, and I've just amended it to create another time series script. So let's just go along to make sure that it's all understandable. Now you see there I've made a mistake. You see it's taking the annual. So that's where that problems of that 2033 comes in. So that must be verse, and that must also be. So always double check your data to make sure. So let's just make sure periods DMSP, 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 DMSP. Just make sure that's all. And in this case, the start, the number is the difference VS. Let's run it again. Shouldn't make. Um, where is? It's now giving me a error. Dot is not defined. End date. Oh, there's a D there that must be out. End date. And there's a D that must be out there. Let's run it again. Here we go. No reds, no errors. So we're all good. So let's just quickly remember to save. Always save. So it's 138 elements. It's not start date start date just make sure, and end date So there's 138 elements. So let's have a look. So number 79 is 11th 2018. So this must be number 80 must be the 12th of 2018 indeed. And so 81 must be then 1st of 2019. That's correct. And our last one should then be the 9th of 2023. So now, as I said, always check these. Even if you don't think much of it, think about it just to make sure your data is the data itself, but you can see um, the labeling is a little bit different. You can look at that. You can see the labels are a bit different, but just to make sure it's correct. Okay. So have a look at this code. We're now standing on about 223 pieces of code or lines of code. So where we initially started by just having 3 or 4 lines of code, we keep on building and building and building on this code. And now basically you've got a code that can do much, much more than just generate a single image. We can now generate many different images. We can adapt our images, we can analyze our image, we can visualize it, we can generate the underlying data of the images, which we can then, as I said, in this case, we can export both the images and the time series for further work. Stay tuned. I hope you enjoyed it in our journey of exploring remote sensing. I think you can agree with me. This is a fascinating a journey to be on, and I hope to see you soon for another exciting video on our journey of remote sensing.